Alright, so the neat thing or the cool thing about vectors is that we can add and manipulate them graphically. So if we drew vectors out to scale on a graph or some CAD software, we can measure the lengths of the vectors that would correspond to their magnitudes. So for an example, let's say that we have forces P and Q acting on particle A. The magnitude of force P is 4 newtons vertically, and the magnitude of force Q is 3 newtons to the right. We want to add these force vectors together and determine the resultant force acting on particle A. So let's use the triangle rule and do this. First, I want to draw a vector P graphically on a regular Cartesian coordinate graph. And notice that I've used 4 units of the graph in the vertical direction to correspond to the magnitude of 4 newtons of the vector force. Next, I'll draw vector Q's tail to the tip of P with 3 units to the right, which corresponds to the 3 newtons of force. If I draw the resultant vector from particle A to the tip of Q, I will have the direction and magnitude of the resultant vector, or the force vector. Since vectors P and Q are perpendicular to one another, we can use the Pythagorean theorem to figure out what the value of our resultant vector is. We find that r is equal to 5 newtons. We can also measure from the graph which direction the resultant force is being applied. If we measure this angle here, which is alpha, we find that the angle is 60 degrees from the horizontal. We can now say that the resultant vector is 5 newtons at an angle of 60 degrees above the horizontal. Graphically, if we drew out vectors or a vector P that had a magnitude of 1 unit and a direction to the right, it would look something like this. If we wanted to increase this vector by a factor of 3, our resulting vector would look something like this. If we wanted to multiply the original vector P by negative 2, we would have a resultant vector that looked something like this. All the factors that we multiply our vectors by are our scalar values.